Welcome to Unity 6 course, the new part. And in this chapter, I create an FPS character, first-person character in Unity. In the previous part, I've explained about the character controller, and we've designed and write a code to move the character controller easily. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. Let's play the game and test it. Alright, as you can see, the character is moving, but I wanna improve it. I wanna add camera at the top of the character here, because we should consider this is the character, this is the character's head, and we should place the camera on this point, which is the character eyes, and we need some extra calculations for the movement algorithm. For example, character should move and change its direction based on the camera. For example, if I input the mouse X here, this direction of the mouse will move along the y-axis, and actually this rotation should be applied on the character controller, on the object. But if I input the mouse Y here, this direction, the character shouldn't rotate in this direction, because actually I'm rotating the character itself. I should rotate the camera for this direction. For the X direction, I should move at the character itself along the y-axis, and for the mouse Y, I need to rotate the camera along the x-axis, and I need to orient the character to the appropriate direction and change it, because when I press the W key, it will move along the Z or X axis, actually the forward direction. And if I don't change the character direction based on the rotation, and if I press the W key, the camera looks at this direction. For example, the forward is this direction, but the character is still in this direction. The character forward is this direction, the previous direction. And we should implement this logic. First, I need to remove these lines, and I don't need to remove this line. The gravity and everything is good. Actually, I need to keep the gravity. It's the gravity code, but I need to create a separate method called apply gravity, and copy and paste these lines here and call it from update. And here we have the gravity effect applied on the character controller. In the next step, I need to create a method, private void movement. I will upload every chapter of the course every week, so make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. Right here, I need to write the movement logic. I need to get the horizontal and vertical and hold them and store them in variables. It is better and organized way. You can write it inline like the previous chapter, but I prefer to create an X input.getAxis, horizontal, and float Y input.getAxis, vertical. Alright, we have the X and Y axis, and now we need to calculate the direction. When I press vertical keys, W and S, I want to move the character in the Z direction. Actually, the Z direction is the forward direction in Unity, the forward of the object. Here, it's the forward, and the X direction is the right direction. Here, if we write transform, the current object we attach the script to it and press dot, we have two properties, forward and right. Right will give me the value of the right direction or x direction, exact value. It's 0, it's 1, 2, 3, -1, -3, and so on. And the forward will give me the exact value of the z direction. So I can here multiply these values, these x's, to the inputs. If I press the A key, the horizontal value, the x value, will be a negative value. And multiply by the right direction. As I said, the right direction is the axis, and I need to move it with the horizontal keys. And if I multiply this value with the right direction, it will be turning to a negative value. And if this value was positive value, the character moves to the right side. So here I need to call the transform.right multiply by x. But we have a problem here. We need to store and hold the result inside a vector tree, because the right is a vector tree and multiplies by the x, all the x's, x, y, and z multiplied by x, and we need to store it inside a vector tree variable. So what about the forward? Because move method, character controller.move method, receives just a vector tree, not two vector tree. And we can't calculate the right direction and hold a separate vector tree variable, and forward direction multiplied by y and inside another variable. We can't. We have something that we can write plus and transform dot forward multiply by y. Here with this operation, actually we combine these two vector trees and we have a unified result. Here we can store it in a vector tree move direction. Now we have an appropriate calculation. Here we can call the controller.move and move direction. And we need to follow the previous steps. Multiply the direction by the movement speed, which we can adjust the movement speed, and finally multiply it by time.delta time. In the previous chapter I've explained about movement speed and time.delta time, the logic of it. If you don't understand this concept, you need to first watch the previous chapter. Right, save the code and let's see. If I press W, actually I forgot to call the movement. Excuse me, we need to call the movement in the update. So now it's executable. Alright, as you can see, I can move the character, and it's slow. I need to increase the movement speed. But now let's work on the camera and add the camera as a sub-object of the character controller. We just need to drag and drop the camera into the capsule, and here let's rename this capsule to player. We need to change the position of the camera here, or here instead of manually changing the position, we can make it 0 and it will go to the center of the player. Actually, this position is a relative position, it's a local position, and if we change it to 0, it will change based on the player or this capsule center. Here we need to move it up, and actually this is the character head, character eye. I recommend don't move it forward. The center section is better. X should be 0, Z should be 0. It's better. I recommend it. And if you want a appropriate first-person character, you need these values. Don't move it forward, backward, right, and left. Alright, let's write the logic. First, I need to define the character camera. Actually, in Unity, we have a camera class, which this class related to this component, but I don't want to use the camera class because I want to change the rotation of the camera, and we need to define a transform. We need to get the transform component of the camera. So here we need to define the transform and camera. Here we have a green underline. What is this? Actually says camera movement dot camera hides inherited member component dot camera. Use the new keyword if hiding was intended. Actually, the MonoBehavior give us a camera variable just like the transform with lowercase t, game object with lowercase g. It will give us a camera with lowercase c. Actually, we redefined the camera variable because MonoBehavior has camera variable. So if we want to redefine the camera, we need to write a new keyword. Here, after private, we can write new, and the green underline has gone. Alright, let's define a method called camera rotation, and now we need to get the mouse X, which is the horizontal movement of the mouse, and mouse Y, which is the vertical movement of the mouse. We need to define the float mouse X input dot get axis mouse X and float mouse Y input dot get axis mouse Y. Now we need to rotate the camera only along the X axis, not Y and not Z. So we just need a float, not vector tree. Here in this case we needed a vector tree because we need to move the controller along the X and Z. But for the camera, I need to rotate the camera only along the x-axis. But instead of defining the variable, the rotation value inside the camera rotation, I need to define it up here because we need to store the previous values. Each time we call the camera rotation, the new variables like mouse X, mouse Y will be gone, and actually they will redefine and they will set to 0, and we don't need this for the rotation because we need to keep the last rotation value. So here we need to call private float and Y rotation. I want to use something that we need a permanent variable that we need to keep the last rotation value. So here we need to minus the current Y rotation from the mouse Y, vertical mouse, or you can use plus. There's no different because if we move up the mouse, the value would be positive. If we move down the mouse, the value would be negative. And we have a simple math operation. Here we have the final rotation, and now we just need to rotate the camera. But the trick is here. We call the camera, and here plus dot, but we need to change the local rotation because camera is the sub-object, is a child, and we need to rotate it along the relative or along the parent. And in this case, we need to call the local rotation. But local rotation receives a quaternion. There is a way to change easily, and defining a quaternion and setting the W, the handler, the helper axis is kind of hard and needs some calculations. But we have a helper method that we can convert a vector tree to quaternion. Actually, we give to that method a vector tree and we'll change it to a quaternion. Here we need to call the quaternion struct struct, as I said in the previous chapters, is a simple class. We can say it's a simple class and lacks some features compared to classes. Here we have a method called Euler, and Euler receives a vector tree and change it to the quaternion. We can create a new vector tree here, inline vector tree, or easily has three values as x, y, and z instead of a vector tree. It acts like a vector tree without creating a new vector tree, as I said, creating and using new keyword each time, and update heavy to compute and adds a pressure, adds a whole overhead to the memory, and some issues to memory defragmentation, and here in this case can use three values. Here I need to send the y rotation for the x axis because I want to rotate the camera along the x. So for the other axis I need to send the 0 and 0, y and z. So we have the three values. Now let's test, but before that let's call the camera rotation in the update. We need to get the values and get the inputs and rotate the camera in real time. Alright, before playing the game we need to assign the camera. We can't use get component because camera is not a component of the player. It's a completely separate game object. We have a way to get the children, but for now this method works. Alright, as you can see I'm moving at the camera and we can move the character itself very well. Now we need to apply the character movement. As I said, we don't need to rotate the camera along the y-axis. Instead, I need to rotate the player along the y-axis. Here easily we can call the transform. We don't need to follow this instruction. We can, but it's not necessary to define another variable called, for example, x rotation and follow these instructions. We can easily call the rotate method, which it receives a vector tree, and here, just like this formula, here we can send something with this directions right forward. But we have another property called up, right forward and up. Up in positioning is the y, but for the rotation, as you can see, y is this direction and this is the up direction for the rotation, and we need to call the up direction if we want to rotate it along the y-axis, rotate an object along the y-axis. Here we can't write transform dot up because it will give us current transform up direction based on the position. I want to rotate it, not move it, and based on the up. But what we need to do if we can't use the transform dot up, because it's variable, this right, this forward or up will change based on some circumstances. We can call vector tree, the vector tree struct, and here press dot, it will give us forward, right, and actually up. It's a raw up value. It won't change based on the character circumstances. It's a constant and it will give us this value. Vector tree, as you can see, 0, 1, 0. We can define a vector tree and put this value 0, 1, and 0. This is same, just looks like the up direction. We can do it like this, but it has overhead. And vector tree has a constant called up. It will help us to prevent from defining a new vector tree and use this up. But if we use the up variable provided by the transform, actually we have different values every frame. And here for the multiplier, for the speed, can multiply it by the mouse X, the horizontal mouse. If we move the mouse like this, the y-axis will be changed. Actually, the character will be rotated along the y-axis. If we don't write the multiply mouse X, it will rotate continuously, and we have an infinite rotation, and the mouse input doesn't affect on the result. Alright, let's save and play the game. Alright, as you can see, we're moving the mouse, and actually the character direction is changing. As you can see, if I press W, it will go forward. If I change the rotation of the camera and I'm pressing the W, and the forward direction is changing as well. Okay, if we need to apply the rotation speed and time the delta time, just like the movement speed, here we multiply the move direction by the movement speed and time the delta time. Question is, can we use the camera rotation speed and time the delta time and the camera rotation? Yes, but easily multiply this mouse X with a value. Let's define a value. Serialized field, private float, camera rotation speed, and the default value should be 1. It's better. Right, and multiply by the camera rotation speed, and then multiply it by time, that delta time. It is possible to do it for the movement. It's mean move this section to X and Y. Yes, it is possible. But as we have just a single line, one line for the movement, and we have a single calculation for the move. And if we move this section up here, actually we doubled. We make it twice calculation, and it's not good. But for the camera rotation, we have already 2 calculations, one for the camera and one for the player, and it's irregular. If we move this line to here and this line here, actually will make it complicated, and it's better to apply these calculations here. And we have the speed. For the final touch, we have a problem. If I play the game, actually for this direction, we don't have any range. Can move it, and here we have an infinite move. And it's not good. It doesn't have any range. The human neck, the human head does not look like this. We can write a logic for limiting the rotation. Here we have a class called mathf and a dot clamp. We have a method called clamp. Actually, clamp receives a variable limited between a maximum and minimum values. Here we need to pass the y rotation as the main value. It should limit. And for the second value, we need to send the minimum value the y rotation should set. For example, -90. This value. This is -90. A camera can't rotate beyond this value. And for the positive, I need to set it to 90, positive 90 for the maximum value. And clamp has a return value float. We need to store it in the y rotation itself. It is possible, right? We've actually limited the camera rotation and play the game. Here we need to set the camera rotation speed. It's very low. It's not good. This value works. Or maybe more. Right, as you can see, it doesn't go beyond. Alright, this is very good, and we have the right logic. Right, good, we have a first person character here easily. Okay, in the future chapters I will explain how to implement the jump logic and actually more advanced features. For example, if we jump, we can't move anymore. And we need to check the character if it's grounded, so we can move. And if not, so we can't. Right? See you later.